We're going. Okay. So again, we're going a tiny bit out of order. We're doing 2-2 instead of 2-1 first, and we're talking about variation stuff. So today we've got direct variation and we have indirect variation. These are things that I think that you guys use, but you don't realize you use them, okay? So direct variation is when your x and your y are related by y equals k times x. Y equals k times x. And in this case, k is a constant. So it's like y equals 2 times x, y equals 3/4 times x. And an example of something that you've seen more often is a equals pi r squared. In that case, pi is my constant and r is my x or my variable. Okay. Similar idea with inverse, except it's going to be the inverse operation to multiplication, so it's going to be a division problem. So we've got y equals k over x, where k is also said constant. Okay. And so the biggest thing we have to look for is it direct variation or is it indirect variation? An example of indirect variation, I believe this is a physics equation, force and direction. I don't know. I should have probably looked into that, but that's an equation I have from last year. So we don't do a lot of inverse variations in formulas that you guys know about from math, but I do think that's a physics one that people see more often. So we've got direct variation, inverse variation, and then we've got one other thing that I want to talk about today, which is power functions. And power functions is when we have a function where x is being raised to any exponent. So x has an exponent. I feel like I wrote it as an equation and I don't remember what that equation was last period. Let's see. Oh, I wrote it y equals kx times a, raised to the a. I wrote it y equals kx raised to the a. So k is still my constant, but then a is any exponent. This is going to be a little bit testing of you guys. That's any number. If I can write it as x to a power, then we're going to use that. That looked like it hurt. So we're going to start by doing BFFs. Can you think of any BFF graphs that are x to a power? Not where x is the exponent, where x is being raised to a power. I heard squared. Good. What else did I hear? Cube. There's a couple more like surprising ones. Which one's 1/2? Not reciprocal. Square root 1. Square root of x is the same thing as x to the 1/2. The reciprocal is 1 though. The reciprocal is the same thing as x to the what power? -1. Good. And then I'm also going to go as far to say the identity, because we can think of the identity as x to the first power. So some of them are very blatantly written 2, 3. Some of them we have to just know the math fact. Radical is square root, rational is 1/2. And then you can also think of x just by itself as x to the first. Excuse me. Okay, so we're going to start these next few problems. It says, write the following statements as a power function equation. We're going to use these expressions, my y equals k times x, and then y equals k over x. And then you might have constants to put in, you might have exponents to put in, all that fun stuff, okay? We have to decide first, is it direct or inverse variation? So if I look at 17, it says the area A of an equilateral triangle varies directly as the square of the length S of its sides. Oh, I listed my way through that one. Keyword there, varies directly. That is my equation, y equals k times x. Y equals k times x. What do you think is going to be my y variable? A, good. And then what's going to be my x variable? S. And then does it tell me what my constant is? Does it use the word constant here? No, when we don't have constant being explicitly told to us, we're just going to use k. So say A equals k s but S has a exponent because it says the square of length S. So we're going to go S squared. Okay. That's all we're doing. We're just writing that, and then we're going to go to the next one. Next one says volume V of a circular cylinder with fixed height is proportional to the square of its radius R. I know this one doesn't say direct or inverse, but we have to assume if nothing specified that it's direct. It is directly proportional. So I'm still going to use y equals kx. What's my y this time? V, good. Notice in the last two that the first one is my y. Always. First one will always be your y. So V equals, do I have a constant? I actually do. They use funny words here. Fixed height. Fixed means that it's the same for all of them. So I'm going to use an H instead of my K. That's my constant. And then what's my X going to be? R. Do I have any exponent with that? Good. R squared. Good. All right, let's do number 19. The current I in an electrical circuit is inversely proportional to the resistance R with constant of variation V. Ooh, this one's different, right? Do you guys see inversely proportional? Mm-hmm. That means I'm using the other equation. What was that other equation? Good, y equals k over x. I'm rewriting mine because I can't see further up the page, but if you can see further up the page, you don't have to rewrite it. What's my y this time? I. And then do I have a constant this time? V. And then that makes my x what? R. Good. So I equals V over R. Do you think you can try the next three by yourself? I'm just going to give you a minute or two. So if you have a hard time, I'll come save you in a minute or two. A minute or two. I've got those next three up on the board if you want to check in with those. I'm happy to explain those too if you want to talk about those. The last one says speed p of a free-falling object that has been dropped from rest varies. It doesn't specify inversely, so we have to assume direct as the square root of the distance traveled d with a constant of variation k equals 2g. So I know that it's direct variation, so I'm using y equals k times x. My y is that first letter, so p counts as my y. Then it says constant variation there at the very end. So I'm going to use square root of 2g as my k. And then my square root of distance d is going to be my x. And then the only other thing is I just combine them to be under one radical to make it look prettier. Yeah, Maddie.
So on 20, if we would put like p equals kt on the place, would that be wrong?
That would be fine. What I just would say is p is actually our constant. So I would try and look for the word constant to help us out. All right, we feeling okay about this? Let's keep it rolling. Next part. Okay. In numbers 1 through 10, it says determine whether the function is a power function, given that c, g, k, and pi are all constants. So if it's a power function, we're gonna state the power and the constant of variation, and if it's not a power function, we're gonna say no. Okay, on the first one, I've got x. What's x being raised to? 5, does that count as a power function? I'm gonna say yes.
Okay, is any number?
X is just a variable. If it's C or G or K or pi, then I have to assume that's a constant or like a whole number or it's a single number. But since it's X, it can be a variable. And that's a variable raised to an exponent, so it's raised to 5, so that makes it a power function. And then what's my K? What's my constant going to be there? -1/2. Let's jump over to number 2. Do we have x to an exponent? Yep, what's my exponent? 5/3, so my power is 5/3, and what's my K constant? 9. Very good. Let's do the next one. Hey, T.
Hi.
Thank you. Oh, perfect.
Thank you.
Thank you. The next one, do I have an x? Is it being raised to an exponent? No, not okay. That is an exponential function, which we'll learn about next unit, but that's not what we're doing now. Number 13 is a little tricky, or number 4 is a little tricky. I like your thinking it's a different one though. I don't physically see an x, so it's x to what power? 0. X to the 1, we would still see x, but x to the 0 is equal to the number 1, which means it's kind of invisible. We don't see it. So I'm going to say this is yes, where my power is 0, and my K, my constant, is 13. Okay. Number 5, remember that before it told us that C is a constant. So C is my constant. It's not the one that's being raised to the power, which makes which number my variable? M's my variable. Is it being raised to a power? This one is being raised to 1. So my power is 1. And then that makes my constant what? C squared. All right, let's do number 6. We know K is a constant, so that means that V is my variable. Is it being raised to a power? Yep. 5. And then that makes my K be, my constant is more than that? 1/2 K. Very good. Yes, Maddie.
So how do we know when there's 2 variables? How do we know which one to come?
Good question. Up at the top, see how it says G, C, G, K, and pi are all constants. So if I see those, I'm going to assume it's a constant. Which helps for the next one, because I've got a G in the next one, but I'm going to ignore that. I'm going to do the T. So T is my variable. What's its power? 2. And what's its constant? 1/2 G. Okay. What about number 8? What's my variable? R. What's my power? 3. And what's my constant? 4/3 pi. Very good. All right, next one. What's my variable? D. What's my power? -2. Why is it -2, not just a normal 2? It's in the bottom. Very good. And that makes my K be what? D is a variable. Okay. K is K. All right, last one's a little funny. I am going to just assume M is a constant, and I may be wrong for assuming that, but we'll pretend that that's correct. And then A is my variable. What's my power here? And then what's my constant? M. Okay. You guys are doing great. I just have 2 more. If I can even just get through one of them, I'll be happy. Okay, did I move too fast? Are we doing okay? Yes, Maddie.
I'm just confused on why the constant was in if it wasn't posted.
Yeah, I kind of made that up. I think that I'm just gonna assume it's a constant. And I will make it very clear what a constant is if I test or quiz you on it. All right, what about number 3? These last two ones are word problems that use the first two equations that I gave you to start the whole day. And we'll just read one sentence at a time. So the first one says the volume of a gas varies inversely as the pressure. Okay, stop. Inverse or direct? Inverse. So what's my general equation going to be? Y equals K over X. Now, it doesn't say anything about constant in that first sentence. So I have a Y and I have an X. We'll find constant in a second. What's my Y here? Y is going to be volume. And then K, we don't know, which makes X what? Give me a word.
Pressure.
Pressure. Good. So I want us to do the first sentence to get my equation. I don't want to plug in too many numbers too fast because I'm going to get confused. Now I'm going to do my second sentence, and that's going to help me do K. So now we can plug in 9.2 for volume and 163 for pressure. So I have 9.2 equals K over 163. So again, I wrote that equation so I kind of know where everything goes. We can solve that very easily for K though, right? Multiply by 163 on both sides. And I get 1,499.6 equals K. Now we're going to use that K and we're going to go back to this equation and we'll read that last sentence. It says, find the volume when the pressure is 74.1. So my pressure, my P is 74.1, and I don't know what my volume is. I can just plug those pieces in and we can divide and solve pretty easily. And I believe I get 20.2. Is that what you guys get? Okay. As much as I want to rush through the last one, we're not going to. You have enough power to start homework. I'm not collecting it till Tuesday, so I'll fully assign it tomorrow. Here we go, guys. We'll finish this problem and then we'll get into Q1 tomorrow.